Hi everybody. So in this video, we're going to continue looking at the loci of complex numbers. In particular, we're going to look at the geometric property of the argument. So we've been asked to sketch the locus of a point that satisfies this statement. We know from previous videos that this z would be a general complex number, and this z1 would be a fixed complex number. So if we begin with z1 and we plot this as a fixed point, let's say here, and then we have another complex number z, which could be anywhere. Let's put this one here. Then we need to look at the displacement between z1 and z, which we can do using vectors. We know if we go back to the origin, so this would be negative z1, and then from the origin we go to z, this would be positive z1. Well, then this will give us z minus z1, the displacement from here to here. So z minus z1. That's exactly what we've got here. And we're going to look at the argument of this. So the argument of a displacement from a fixed complex number to a general one. And we're told that this must always be equal to theta. But we know that theta must always come from a direction which is parallel to the real axis. So theta must come anti-clockwise in this direction. So then the locus of a point from z must always be along this line. For instance, if its location was here, well, it would still have a displacement of z minus z1, and the argument from a direction parallel to the real axis would still be theta. So we call this locus, this red line, we call this a half line, because it doesn't go on forever in both directions. It cannot go beyond this point, because if it did, the argument would be different. And actually, it cannot be equal to this point either, because if it was, then the angle would be equal to 0. So we can show this as a hollow circle at the point z1 and the half line travelling in this direction, which is theta degrees anti-clockwise from a real axis. Okay? In the next example, I'm going to show you how to sketch the locus when we have a fixed point in x plus iy form. Okay, so in this example, we've been asked to sketch the locus of a point in the Argand diagram that satisfies this equation. And we know that the argument of z minus z1 must always be equal to theta. So we need to begin by identifying z1. So the argument of z minus, well, we need a positive 3 here, because when you multiply this out, it becomes a negative. And then we need a negative 2i to make this positive 2i. This negative times this negative would make that positive, and that will be equal to pi over 4. So now we know that z1 is located at 3 and negative 2, which we can plot about here. So it's got a real part of 3 and an imaginary part of negative 2. And we know it comes from a direction which is parallel to the real axis at an angle of pi over 4 anti-clockwise. So approximately here, we'll label this as pi over 4. So we know that with general complex number, z could be at any point along this half line, but it cannot be equal to the point 3, negative 2, because then the angle wouldn't be pi over 4, it would be 0. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.